blockchains are widely replicated, any data stored in a blockchain is highly resilient and can survive even if a copy of a blockchain is corrupted or if a node on a network fails. So long as a valid copy of a blockchain exists somewhere in the world, a blockchain can be restored and replicated by others to retrieve past records and engage in new transactions. To ensure the orderly recordation of information and to enhance a blockchain's security, every blockchain incorporates a consensus mechanism, a set of strict rules with predefined incentives and cost structures, which makes it difficult and costly for any one party to unilaterally remove or modify data stored on a blockchain. Consensus mechanisms help a blockchain-based network periodically reach agreement as to the current state of the shared database, even if members do not know or trust one another. By weaving in public-private key cryptography, each blockchain validates the integrity of data recorded to a blockchain and enables people to engage in transactions pseudonymously without necessarily revealing their true identity. Because blockchains are not centrally maintained, no single party necessarily needs to control access to them. By implication, on publicly accessible blockchains, anyone can create a blockchain-based account, comprised of a public address and a private key, a password, and engage in transactions with others with limited fear of third-party intervention. More advanced blockchains also integrate decentralized computing systems, in other words, a distributed virtual machine, and Turing-complete programming languages, enabling parties to write and deploy smart contract programs. These programs are stored on a blockchain and executed by multiple members of a blockchain's underlying peer-to-peer network, creating computer processes that are autonomous and potentially difficult to shut down once deployed. Since the launch of Bitcoin in 2009, blockchains have underpinned an array of online services that seek to use the technology to store information and run computer processes. Some of these applications aim to fulfill May's vision, while others help enhance existing lawful services. As Bitcoin has demonstrated, blockchain technology supports decentralized, global value transfer systems that are both transnational and pseudonymous. Using a blockchain, anyone can exchange digital currencies, such as Bitcoin or other valuable assets, without the need to rely on a centralized clearinghouse and without affirmatively disclosing their identity. Blockchains are sitting behind novel peer-to-peer remittance systems that decrease the cost of sending funds abroad, and the technology has found an early foothold in the financial services industry, powering new decentralized systems that strike at the heart of global finance, including decentralized securities and derivatives exchanges. In just a few years, the reach of blockchains has rapidly expanded beyond payments and financial products, helping to support new autonomous systems that structure social and economic interactions with less of a need for intermediaries. Smart contracts are being used to memorialize all or parts of legal agreements, creating commercial arrangements that are dynamic and potentially harder to terminate. Governments across the globe are experimenting with blockchains to secure and manage critical public records, including vital information and titles or deeds to property. By leveraging the tamper-resistant, resilient, and non-repudiable nature of a blockchain, governments are looking to guarantee, with a high degree of probability, the integrity and authenticity of key governmental information. Over time, blockchains could anchor new public infrastructure and potentially even global and transnational systems available to anyone with an internet connection. Blockchains are also beginning to structure collective endeavors, including new forms of digital organizations administered, at least in part, by code. Because blockchains are widely accessible and can facilitate economic transactions, they are being explored to manage the operations of existing legal entities, serving as a central point of coordination, with smart contracts implementing code-based rules that could decrease the cost and difficulty of managing group activity. Blockchains are even powering new forms of organizations that are more transparent and less hierarchical, helping disparate groups of individuals come to an agreement without having to know one another. Because blockchains enable the execution of autonomous code, over time, they may also provide the infrastructure to create organizations that rely entirely on algorithms.